Today on Orbital Dispatch, why dead Mars probes eventually crash into the planet. We will break down what happened and why it matters. MAVEN, NASA's Mars atmosphere probe, will crash into the red planet within the next century. This isn't an accident. It's basic orbital mechanics at work. When we send spacecraft to orbit Mars, we're essentially putting them on borrowed time. Unlike satellites around Earth that can stay up for decades, Mars orbiters face a unique challenge that guarantees they'll eventually come crashing down. The key difference lies in what's happening in Mars's upper atmosphere. Earth's atmosphere creates drag on low-orbiting satellites, yes, but it's predictable and manageable. Mars presents a completely different problem. The Martian atmosphere problem. Mars has an incredibly thin atmosphere, less than 1% the density of Earth's. You'd think this would mean less atmospheric drag, but the opposite is true for orbital mechanics. The thin atmosphere extends much higher than Earth's dense layers, reaching altitudes where Mars orbiters typically operate. MAVEN orbits between 150 and 6,000 kilometers above Mars. Even at those heights, it's constantly encountering atmospheric particles. Each encounter slows the spacecraft down slightly, gradually shrinking its orbit. It's death by 1,000 tiny bumps. Why Mars orbiters can't escape this fate. On Earth, mission controllers can fire thrusters to boost satellites back to higher orbits. The International Space Station does this regularly. But Mars missions operate under strict fuel constraints. Every kilogram of propellant costs millions to transport to Mars, so spacecraft carry only what's absolutely necessary for their primary mission. MAVEN has already been operating since 2014, well beyond its original 2-year mission. Its fuel reserves are carefully managed to maximize science operations, not to fight orbital decay indefinitely. The mathematics are straightforward. Atmospheric drag is constant, fuel is finite, so eventually drag wins. The calculated end. Mission planners don't just accept this fate, they plan for it. Mars orbiters are designed with their eventual crash in mind. Controllers aim to extract maximum scientific value before the spacecraft's orbit becomes unsustainable. MAVEN's crash timeline isn't precisely predictable because Mars's atmosphere varies with solar activity and seasonal changes. During solar maximum periods, increased solar radiation heats Mars's atmosphere, causing it to expand and create more drag. During solar minimum, the atmosphere contracts, giving orbiters slightly more time. Current estimates suggest MAVEN will impact Mars sometime in the 2030s, though this could shift by several years, depending on solar conditions and any remaining fuel management decisions. What happens during the final descent? When a Mars orbiter finally succumbs to atmospheric drag, it doesn't simply drop like a stone. The spacecraft spirals inward over its final orbits, encountering increasingly dense atmospheric layers. Most orbiters break apart during this process, with fragments scattered across the Martian surface. Mission controllers typically maintain contact until the very end, gathering final atmospheric data during the death spiral. In many ways, these final moments provide some of the most valuable information about Mars's upper atmosphere, data that's impossible to collect any other way. A planned obsolescence. This inevitable ending isn't a design flaw, it's a feature. Mars orbiters live fast-paced scientific lives, collecting years of data in orbits that would be impossible to maintain long-term. The alternative would be parking them in much higher, stable orbits, where they'd be too distant to perform their primary missions effectively. MAVEN has already revolutionized our understanding of how Mars lost its atmosphere billions of years ago. Its eventual crash will mark the end of an extraordinarily successful mission, not a failure of engineering. Every Mars orbiter follows this same path. They arrive, perform brilliantly for years, beyond their planned lifespans, then gradually succumb to the same atmospheric forces they were sent to study. It's poetic in a way. These spacecraft become part of the world they spent their operational lives observing. If you found this exploration of orbital mechanics interesting, you'll appreciate our other deep dives into spacecraft engineering and planetary science. Main takeaway: the evidence is still evolving. Subscribe to Orbital Dispatch. Next, our next breakdown.